This video is for section 2-2, simplifying expressions. Because the variables in polynomials are real numbers, we can use all the axioms and properties of real numbers that we've learned about to simplify the polynomial. Simplifying means to perform the operation shown in the polynomial. Here's an example. Let's take this binomial and add this binomial. Remember that adding is commutative, so the order of the terms can be rearranged as needed. We could write the 6x squared and the plus x squared side by side, and then write the minus 2x and the plus 4x side by side. This makes it easier to see the like terms to combine them. 6x squared plus 1x squared is 7x squared, and negative 2x plus 4x is positive 2x. If you want to, you can go directly to the final answer without writing this intermediate step. Just look across the entire problem, and without rearranging anything, find the like terms so that you can combine them. By simplifying this expression, we have created an identity. An identity is an equation that shows expressions are equivalent. In our example problem, here is one expression, and then we have equals, and then here is another expression. And these are equivalent to each other, so this equation is called an identity. Here's another example of an identity. 12 minus 8 equals 4. It's an equation that shows that two things are equal to each other. Here's another example problem for simplifying. This time, let's not take the time to rearrange the terms, but simply look for like terms. I'm going to begin by locating the highest degree term. That's the 5y cubed. There are no other y cubes, so my answer will begin with 5y cubed. Now I'm going to look for y squared terms. 3y squared, and later plus negative y squared. A 3 and a negative 1 combines to a positive 2, y squared. Now the y terms. Negative 7y, and later positive 7y. Negative 7 and plus 7 makes 0, so we don't need to write a y term at all in the answer. And now the constant terms, 4 plus 2. That makes positive 6. So this polynomial is the simplified version of the original one. Next, let's discuss subtracting a polynomial. To subtract a polynomial, use the property of the negative of a sum. This was one of the first axioms we learned this year. Let's rewrite this question by applying that theorem. The first polynomial will stay the same. Then we'll apply the theorem to handle the subtraction part. Subtracting 7b squared is the same as adding negative 7b squared. Subtracting a 5b is the same thing as adding a negative 5b. Subtracting a negative 1 is the same thing as adding a positive 1. Another way to think about how that is rewritten is to think of distributing the subtraction sign to each term in those parentheses. The subtraction distributed to the 7 makes negative 7b squared. The subtraction distributed to the positive 5 makes negative 5b. The subtraction distributed to the negative 1 makes positive 1. Now that the problem is rewritten as an adding problem, we can add like terms. 4b squared and negative 7b squared is negative 3b squared. 3b and negative 5b is negative 2b. And negative 2 and positive 1 is negative 1. This polynomial is the simplified version of the original problem. You'll notice that to get these coefficients figured out, it is absolutely critical to be able to add and subtract positive and negative numbers. Let's summarize how to simplify a polynomial expression. To express a sum or a difference of polynomials in an equivalent form, you add, or if you're doing a difference, you subtract the coefficients of like terms. Most teachers and students refer to this as combining like terms. Next vocabulary word is formula. A formula is an equation that gives an expression for one variable in terms of other variables. Here are some example formulas that you may have seen before. Area equals length times width. The variable A is written in terms of L and W. Celsius equals 5/9 times Fahrenheit minus 32. The variable C is written in terms of the variable F. Kinetic energy equals 1/2 times mass times velocity squared. The variable K is given in terms of M and V. The last one is the compound interest formula to figure out how much money is in an account after it accrues interest over time. We can evaluate a formula by finding the value of one variable when given values of the other variables. Let's try two examples. Find the area of a rectangle given its length is 3 feet and its width is 5 feet. The formula that applies is A equals L times W. We want to find the answer for A when we know the length and the width. Substitute 3 for length and 5 for width. And 3 times 5 is 15. Area is measured in square feet. Next example, let's find the Celsius temperature when it's 212 degrees Fahrenheit. The formula that applies is C equals 5/9 parenthesis F minus 32. We want to find the answer for C when we know the value of F is 212. This makes 100 degrees Celsius. Let's summarize the lesson. We reviewed what it means to simplify a polynomial by combining like terms. We also discussed math formulas and how to evaluate a formula by substituting known values in for all of the letters except one. That allows you to find the value of that one variable.